Hi, so in this video, we're going to be looking at how to not suck at making graphs. And before we actually get into making our graph, and I would encourage you to follow along and see if you can end up with the same graph that I create, we're going to look at kind of where we got this data. So I have this bowling ball, and the bowling ball is around 14 pounds. But I want to find out what that is in kilograms. And I don't have an easy way to convert it. I'm not going to go to Google, anything like that. But instead, what I've done is I've pushed it with a known force, and I changed the force a few different times. And so I was pushing to the right, and I was kind of the net force that was making it accelerate. And I had some motion sensor, some kind of thing over here that essentially was taking data as the bowling ball rolled to the right, and I got these acceleration values. So I have a net force, I have an acceleration, and we know from kind of previous that Newton's second law, there's three laws that Newton had. The first law says that something in motion or at rest will stay the way it is unless a net force acts on it. The second law is the one that we care about today, which is saying that the net force will cause a mass to accelerate. And keeping in mind that acceleration means that something is either speeding up or slowing down, or it's changing direction. Now, in the case of my bowling ball, it's going straight, so it's not changing direction, but it is going to go faster and faster and faster. And so the harder I push consistently, the greater it speeds up. Now, the neat thing with this is this actually kind of matches something you're intimately familiar with, or at least I hope you are from a math class in your past. And it's that y equals mx plus b, which is this slope intercept form that kind of makes a line. And so really by looking at this, we can see that if we plotted the net force as our y thing and we plotted acceleration as the x thing, we'd find that, well, our slope would give us the mass. M happens to be m in this case. The slope is the mass. Also keeping in mind that this is assuming that there is no other thing here. So really we're just saying that b is 0. So really what I want to do here is really just take kind of all my data, and we'll just plot acceleration here. We'll plot the net force here. We should hopefully get something that looks like a line, because this does match our slope intercept form, kind of this linear equation form. And so we get some data hopefully, and from the data we can take a line of best fit. And the slope of that should give us the mass of my bowling ball. I know it's 14 pounds, but what is that in kilograms? So now, kind of jumping into the actual spreadsheet portion of it, I have a Google Sheet. I typed in exactly all of this data that we were just kind of looking at, and I want to make a graph now. And there's a couple ways you can do it. You can just highlight everything by left-clicking once and then just going insert chart. But oftentimes, this really turns out with like an awful graph a lot of the times. And we can see actually something really nice here, is that at first glance, this looks good. This looks like a great graph is what I originally thought. But I'm looking here, and we wanted to have force on the y. We wanted to have acceleration on the x. Sorry about that. We want to have acceleration on the x, but what Google Sheets has done here is it has done the exact opposite. I don't want them flip-flop like this. I really want to see them exactly how I want them. So I'm going to delete this. I just want to start with a brand new graph here. So I'm going to go and click out of this. Just click on an empty cell and go to chart. I just want to insert a chart. And we go, well, I have no idea. It's just there's no data. Perfect. It's exactly what we want. And it'll automatically pop up with your chart editor. And the setup is really all about kind of the information that your graph will be showing. The customize is more how can you make a title? You can change colors. You can do the line and best fit. You can add units, all of that. The setup is really what kind of chart, like how's it fundamentally going to look? And so right off the bat, I don't want a column chart. I can't, pretty much every graph we want a scatter chart. And we want to just pick the x-axis and then later the series, which really is how Google calls the y-axis. So my x-axis, we said we want acceleration. So I click here. I click on the little window pane that lets me select a data range, and I have to click into the box, and then I'm just going to say acceleration, and it knows that this is this sheet, and it wants cells B5 through B10. Terrific. Okay, so there we go. But we don't see anything yet because we need to have a Y set of values. So now I click series, and I want to click the window pane again here. We're going to add a series. So I've clicked in the box, and now I want to use our net force. Wonderful. I click OK, and ta-da, we have a beautiful linear graph. It looks like it's kind of chopping a little bit, but it doesn't look half bad. It looks linear. It looks how I want it to look. So what are the next steps now to finding the mass of, well, my bowling ball? So I want to put a title, I want to put axes, I want to do all the things that you normally would do for a graph. So these are all going to happen over in this customize tab where I said earlier. We're not going to put the charts style really. I don't really mess with that often. You can go to maximize and it'll kind of make it bigger and kind of do things. But really, we want to look at the chart titles and axes mostly. And the format for a title is always the Y thing versus the X thing. And so in our case, we wanted net force on the Y. So I'm going to change my Y thing to net or net force, and the X thing is the acceleration. You could say of a bowling ball, or we could just leave it as it was. And if you don't like this odd kind of gray color, you can change the text color. I would much rather have it as black. It just kind of pops a little more. But then where it says green in chart title here, we're going to go and change the subtitle and the horizontal and the vertical. So subtitle, usually put your name. You can change the color if you want. For kind of speed's sake, I'm not. Then here we said our x-axis was acceleration. That's in meters per second squared. You can put a little caret, put it squared, or you just go per second. Both of those work. We'll go to our vertical axis, and this was net force, and net force is in newtons. And there we go. So it looks pretty darn good. You can click on here. You could kind of change the size, kind of scrunch things, do things like that. But now here's the big one. How do we get the line of best fit? So this is not here in the axes and titles. It's under series because it cares and it's kind of looking at the series of data that we actually have here. So all I'm going to do is scroll until I see where it says trend line. I want to check that box. Ta-da, it's there. But there's no equation for it. So we need to find where it says label. It says none. We want to go use equation. Excellent. And if you don't like your graph floating in the middle, you can grab this and just kind of drag it up. And so that's really it. There's a couple other things that we could play with. If you don't like how it kind of seems like it chops, it doesn't really have a zero here, you can absolutely change your horizontal axis. You could change your vertical axis. You could make it so that the minimum is 0 for the horizontal. You can make it so that X is 0. So it really kind of like, it kind of can polish it up, do kind of whatever you want with it. I personally don't like how it's cutting off my last dot here. So I want to change my horizontal axis. So it actually maybe goes to, I don't know, 10, or no, not 10, but 8. I want to make sure that that actually goes all the way to 8. And then I probably need to go and fiddle a little bit with my vertical axis so that it maybe goes not just to what it says as max, but maybe just 50 might actually kind of clean that up. Or maybe we want 55, something like that. That makes it go to 60. But you can play with this in all sorts of ways. So now that we have this equation. It's something equals our F net equals 6.35x plus blah, 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 blah. So we have a y-intercept. This means that my data isn't perfect, but it's pretty good. This number is close to 0. But we said previously that the slope of this graph would be the mass of our bowling ball. And so this really just means that, well, the mass of my bowling ball is 6.35 kilograms. And if we did go into Google and go from pounds to kilograms, and I said my bowling ball is 14 pounds, well, there we go. We get my 6.35. So it actually does check out. The graph makes sense, and that's how we do it. Thanks for watching.